This is Suvarchala working as an associate professor in the Department of Computer Science and Engineering at IARE. It's a part of the lecture series on database management system. In this session, I'd like to discuss about hashing techniques. This is one of the indexing technique used to store our data so that effective and efficient retrieval of data can be considered. As we discussed in earlier sessions, various kinds of indexing techniques are available to us: order and unorder indexing techniques, tree indexing techniques, hash indexing techniques, etc. So, part of that, one of the indexing structure, most popular indexing technique used to store our voluminous database is hashing. Hashing used or implemented on disk files is known as external hashing. As external sorting is there, similar to that external hashing. That means in this hashing technique, we are going to use the secondary storage device to store our data temporarily. And the file blocks are divided into m equal sized buckets, numbered bucket number T0, T1, T2, etc., Tm-1. Typically, bucket corresponds to one disk block, or sometimes it depends upon the area of the or size of the block also. It may be that is fixed number of each bucket will have some fixed size actually. So that's why it may be a one block or two blocks, etc., depending upon the block size and depending upon the data, etc. One of the file fields is represented as a hash key. One of the attributes or one of the uh, column, one or combination of the columns is considered as a hash key. That is based upon that particular key value only, the data will be stored in various buckets so that retrieval can be done most effectively. How to map which key is to be stored in which bucket? For mapping, a function is used known as hashing function. This function, a combination of some mathematical operations, etc. So the record with the hash key value k is stored in a bucket I such that I is equal to h of k, where h is the hash function. That means on key value, a hash function is going to be executed. Whatever the value we are going to get, that particular value will be considered as bucket number. And if we able to identify bucket number directly in that small area of the bucket size, the data can be searched for and retrieved also if necessary. That is, search is very efficient on the hash key. Only one computation is sufficient. On hash key function, the direct bucket size number is there. Within the bucket, we have to consider for searching either by linear or binary, etc., depending upon the way we are arranging the data in a bucket. Collisions are, whenever we are mapping such a way, collision occurs when a new record hashes to the bucket that is already full. So when we are doing this mapping function, for various values, we will get the same bucket number also. That means it all depends upon the function which we are using actually. So once the bucket is full, then where we supposed to get store the new data which is mapped to the same bucket, then we will call it as a collision occurs. That means a overflow also occurs. An overflow file is kept for storing the such records. That means additional buckets are added to that. Various techniques are there. We'll discuss that. That overflow records that hash to each bucket can be linked together, and we will call it as a chaining technique also. That we'll discuss a little bit elaboratively further. This hashing is going to be categorized into two categories, that is static hashing and dynamic hashing. The terms itself indicates in case of static hashing, the function and the number of buckets allocated to store our data is fixed. Depending upon the hash function, for example, mod function is a hash function. V mod 5 is a hash function. V mod 5 means all reminders. What are the reminders we will get? 0, 1, 2, 3, 4. Right, up to 5, no? That means 5 reminders we will get. That means 5 buckets can be addressed. The address of each bucket is 0, 1, 2, 3, 4. Like that, 5 buckets are there. So, if more data is going on increasing, then automatically number of buckets to be increased, but which is not possible because of our hash function. Hash function cannot be changed, no? So, even bucket numbers are also cannot be changed as hash function is reminders. So, additional data, whatever more data we are getting, the data is going to be attached to the existing buckets itself. Then again, it will be general linear search process, which will take more time also. So that's why the static hashing means here, the hash function is going to be fixed, the number of buckets are going to be fixed. If the data in your database is having a frequent increase, that means volume of the data is going on increasing and decreasing drastically. In such cases, static hash function is not that much suitable. Then we will move to the dynamic hashing function. So these two techniques we'll discuss today in this session, a brief manner. So we'll define first basic definitions. A bucket is a unit of storage containing one or more records, just like a block of memory, right? In hash file organization, the bucket of a record directly from its search key value using hash function, using a mapping function actually. Hash function H must be selected in such a way that all search keys will be mapped to the set of the buckets given in addresses, some addresses, B addresses. That is, fixed number of addresses of the bucket addresses are available. Those to those buckets, it has to be mapped actually. Hash function is going to be used to locate records for access, insertion, as well as deletion also. So we can insert a new record, we can delete the records, existing records. So such a way the management of the data in our buckets are going to be considered actually. Records with the different search key values may be mapped to the same bucket. So entire bucket has to be searched when the respective bucket number was evaluated based on hash function. Within the bucket, again, the searching will be linear search only. So, for example, here, a hash function file organization example, there are 10 buckets are there. The binary representation of ith character is assumed to be integer I. The hash function returns the sum of the binary representations of characters modulo 10. So, some of the, let us assume, a complex functions are also can be used actually, hash function. This is one of the function example. That means the key value will be there and the key value binary representation will be there and ith character is assumed to be as having integer I. The hash function returns the sum of the binary representations of the characters. That is, if there are n characters are there and 1 plus 2 plus 3 etc. up to n characters, the binary representation is going to be considered and some of the binary representations of these characters modulo 10. Modulo 10 means, just now I told you modulo find, similar to that. Modulo 10 means reminders. So whatever the value you are going to get for any key value, that is divided by 10, the reminders are constant. So how many buckets are there? Depending upon the number of reminders. Here 10 reminders we will get 0 to 9. So bucket numbers are going to be 0, 1, 2, 3, 4, etc. For example, music 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 means the integer values ith means here 1, 2, 3, 4, 5. Some of these numbers are going to be 6, 10, 15. Right? So we have to consider this binary representation. Instead of taking decimal representation, the binary representation has to be considered. Then sum them. And divide it by 10. So the remainder, whatever the remainder I am getting, that will be 1. Similarly, H of history, H of physics, H of electrical engineering. That means each character is first considered as an integer. First character as a 1, second character as 2, etc. Convert them into binary representation, and then some of those binary representations are going to be considered as a total value and divide by 10, and the remainder will be the bucket number in which the respective key will be stored actually. Key will be stored means the address of the key will be stored. Then automatically, directly, the header will be moved to the respective address in your secondary storage device, and the data will be accessed directly. That means the hash function is going to be accessed directly data from your buckets only. So this is an example, bucket 0, 1, 2, 3, 4, etc. 7 buckets data was there. Whenever a reminder comes, then if the reminder is 1 means for a respective value, bucket 1 will be stored. Reminder 2, the respective records are stored in the bucket 2, and so on and so forth. That is instructor file we are using. Let us assume that based upon the instructor ID, this was stored. In such cases, the representation of these, depending upon the number of buckets, or depends upon the hash function which we are using here. And the effective hash function generally makes us to retrieve the data almost to same time actually. Almost the same time. It's not the same time correctly. Almost the same time actually. But the function is a worst function, then it makes most of the values are going to be mapped to the 1 or 2 buckets only. Then automatically overflow occurs. Then it becomes a linear search only, similar to linear search only. So to avoid that, an ideal hash function must be chosen by us. So an ideal hash function must be uniform. Uniform means whatever the range of values are there for key values, all of them must be mapped with almost all different buckets. That means there should not be some buckets empty always. There should not be some buckets always overflow. Such a way we have to identify the hash function. That is depending upon the range of the key values, and hash function has to be generated. So that what happens? The records are going to be uniformly mapped to the buckets, almost all buckets actually. So such function is known as ideal hash function. So ideal hash function must be uniform. That is, each bucket is assigned the same number of search key values from the set of all possible values. That is, first bucket 2, 3, second bucket again 2, 3, etc., etc. Right? So not some buckets are empty and some buckets are going to be full, and connected overflow buckets are also connected to that. Generally, an ideal hash function is going to be considered as a random function. That means each bucket will have the same number of records assigned to it, irrespective of the actual distribution of the search key values. If it is random, means randomly it will be bucket number will be selected. So that's why irrespective of the actual distribution of the search key values, randomly the bucket number is allocated. Then generally it may be uniform also. The hash functions are going to be perform computations on internal binary representation of the search keys. For example, search key is a string. Then binary representation of all characters in the string could be added, and some modulo of the number of buckets could be returned, which we discussed previously. And assigning and inserting and deleting is not a problematic issue in our hashing technique actually. The major issue is going to be how to handle overflows, bucket overflows. Bucket overflows means if the data is more, insufficient number of buckets are available, then some of the buckets are going to be full, then additional buckets are going to be added. Those additional buckets are known as overflow actually. That means if whenever we are searching for a particular key value, if it returns a bucket number, if it has additional chaining of the buckets, then we have to search for that value in this chain of buckets of memory in a linear search manner. So that is, this overflow occurs because of insufficient buckets, that is the data. For example, 3 buckets are there, each bucket may consist of 10 records, but I have 100 records, then automatically possibility of overflow is there actually. So insufficient number of buckets and skew in distribution of records. As I told you, most of the key values are going to be always assigned to the same bucket, then a skew will be generated. Same bucket, skew tree is there, no, one side only we will consider. Similar to that, only 1 or 2 buckets are going to be always returned based upon different values. So more number of records to be stored in the same bucket. And this skewness of the situation occurs due to the 2 reasons. One is multiple records have the same search key value, then automatically we will get the same bucket number. And the second, as I told you earlier, the hash function which we are going to choose produces non-uniform distribution of the values. As I told you, ideal hash function must be uniform distribution. But it is because of the non-uniform distribution of hash function also, this type of skew in distribution of records may arise actually. And moreover, more records are there. Multiple records are having the same search key value. Those are going to be assigned to the same bucket number. So, the probability of bucket overflow can be reduced, but which cannot be eliminated in static hash function. So, it is handled by using overflow buckets. So now you just observe this, we will call it as a overflow buckets or a overflow chaining. In this example, you observe bucket 0, bucket 1, bucket 2, bucket 3 are there. For bucket 1, if after full, a new bucket is added, connected as with a link. Again, second one also full, third one. That means more number of records are resulting the address of the bucket 1 as a result. So all those records are stored. These are called overflow buckets. The original bucket and additional buckets which we attached, these are called as the overflow buckets for bucket 1. Similarly, for every bucket, you can have some overflow buckets depending upon the data to be stored in the respective bucket actually. Overflow buckets of a given bucket are chained together by using a just linked list. So, once you identify the bucket number, to search values, I have to use only linear search in the first bucket, then connected second bucket, connected third one, etc. All over buckets related to one must be searched. This type of hashing technique is known as closed hashing technique because we cannot change our number of buckets, no? So once fixed, that is going to be final. So 3 buckets are there, total 4 buckets, bucket 0, 1, 2, 3 are there. Even more records are need to be stored. A overflow bucket is added, but not these bucket numbers are going to be increased. Because of this overflow increase of the overflow buckets, no, then automatically time taken to search or insert will take more time because linear search process is there. So an alternative technique is there, hashing technique. We will call it as a open hashing. In this open hashing, no overflow buckets are going to be used, and then this is not suitable for our database applications. Closed hashing, open hashing. In case of closed hashing, the number of buckets are not sufficient. Additional buckets are added to the existing addressed buckets as overflow buckets. Then the hashing is known as closed hashing. Open hashing means here the overflow buckets are not allowed. If it is not sufficient, you cannot store it all actually. That means such type of closed hashing is not at all suitable to our database applications. Why? Because our database applications are most of the time data is going on increasing or decreasing actually. So that's why in such cases it's not at all possible actually. And hash to file overflow, just now as I specified, 340, 460, etc. stored, null pointer, similarly bucket 1. And if it is not completed, no, 3 records are completed in the bucket 1, 321, 761, 91. Again, 981 also come, then the pointer is point to the overflow bucket, etc. This process is continued. Like this, you can pointers to the records within the overflow buckets can be identified. Hashing can be used only for file organization, not only for file organization, but also for index structure creation also. We will create indexing or indices on a file and we can delete indices also. During the process of searching and on a particular attribute, indices are going to be created by us for efficient processing of the data, efficient searching of the data. After completion of the application, indices can be dropped also. So, not only for storing our data in our files, this hashing can be used as an indexing structure also. The hash index organizes the search keys within their associated record pointers into a hash file structure. That means these hash indices are always secondary indices actually. The file itself is organized using hashing. A separate primary hash index on it using the same search key is unnecessary. If any other search keys are there, then you can use indexing secondary search key. So, whenever you are using matching the bucket numbers, the respective block addresses will be there. Internally, how it will be arranged. This is bucket number, right? So, here address is there. Because bucket means I told you already memory actually, block of memory. So where it was stored, that block address is going to be assigned. So whenever the data stored means in this block of memory will be stored, right? So here this bucket address is going to be stored on the disk first. That address gives the block address in which the respective bucket data was stored actually, to be stored or stored actually, right? So in such a way, we have to manage the hash indexing concept by using static hash function actually. So another example is given. You observe here instructor data is given based upon the attribute ID. The buckets are going to be generated. Here you observe the data was stored somewhere. That is the pointer are going to be pointing here. That means bucket 0, 76766 is there. The pointer to that particular record is stored actually. So that means here, this is indexing. Indexing means only the bucket number and the record attribute value, its address will be stored, not but the entire data. If it is a file, the entire data will be stored actually. Same concept you can use. Pointers are used to address them to where it is stored physically actually. And whenever you are accessing, for example, I would like to access 10101, then I'll apply hash function, I'll get 3, I'll go to the bucket 3, here the first record itself is there, here address of the record is there, directly we will move. So the number of computations are very less to access the respective data, then automatically it can be easily accessed and the time taken to access such data is also easy. Such type of indexing can be generated. Hash indices are going to be generated on any attribute. But the attribute which is already a hash indexed, while storing the file itself, no need to one. It is a repetition unnecessarily. But the remaining attributes we can use so that they will consider it as a secondary indices. As we discussed now, there are many deficiencies of this hashing technique, static hashing technique. In static hashing technique, the hash function maps to the search key values to a fixed set of buckets addresses. So that's why if the database is grow or shrink along with the time, then this type of indexings or this type of storage is not at all suggestible. Because if initial number of buckets are not sufficient, so we are keeping on adding overflow buckets, then automatically search process will take more time, more number of overflow buckets are added actually. And also space is also allocated for anticipated growth and because always whenever we are creating a hashing indices or a hashing file organization, 50% of the bucket only should be get filled initially, because the remaining part is going to be get filled depending upon the operations, day-to-day operations we are going to perform on our database actually. That's why if the database shrinks, again space will be wasted. If the database grows, the space is going to be insufficient. So that's why generally what happens in real-time applications, even static functioning, because easy to implement, that is one of the most advantage of our static hashing actually. So every time it is going to be reorganized periodically. For example, depending upon the growth or a shrinking of databases available from time to time, depending upon the time period, the periodic reorganization of the file with the new hash function is going to be considered. That means more number of buckets to be added because hash function is going to be changed, or less number of buckets to be added if the more shrinking of database is there actually. But what happens, if you are suggesting that, orally suggesting such thing, reorganizing the data or reorganizing the file, but it will take more time and it will take more cost also. That is, it's very expensive and it disrupts the normal operations. When I'm going to do a reorganization of this file, means reorganization of data will be there. During that period, no transactions are going to be allowed. So that means during that period, our all applications are going to be idle. So that's why it disturbs the normal operations, which is against to the real-time applications actually. And the better solution is allow the number of buckets to be modified dynamically. So that's why it's not possible reorganization. Reorganization leads to many errors. So that's why it's a better number of buckets are going to be increased or decreased dynamically as per the size of the database actually, as per the number of records are available in our file. So this leads to the next hashing technique known as dynamic hashing. So what is dynamic hashing means? This dynamic hashing technique is going to be used to store our data by using hashing only, but the number of buckets are not going to be fixed. It's a dynamic. That means the number of buckets may be increased or may be decreased depending upon the size of the database is going to be varying actually. It's very good for our databases which grows and shrinks in size very frequently, and it allows the hash functions to be modified automatically, dynamically, and automatically it allows the data organization also without disturbing our day-to-day operations of the database actually. So an example for this dynamic hashing technique is extendable hashing actually. So extendable hashing is based upon the binary address of the bucket actually. This is one form of the hashing, and this hash function generates the value over a large range typically bit integers. For example, our B may be 32. 32-bit address of my 32 bits means all 32 bits need not be used, 32 means we are going to get 2 power 32 combinations are there. 3 bits means 2 cube. 4 bits means 2 power 4. Like that, 32 bits means automatically 2 power 32 combinations are available. But all of them may not be used, depending upon the size. So we may be using initially less number of bits. After that, more bits are added. Automatically, more buckets are going to be added actually. So the length of the prefix bits will be 0 less than or equal to I less than or equal to 30t. Then bucket address is going to be the table size is equal to 2 power I. Initial I is equal to 0. 2 power 0 means 1. 2 power 1 means 2. 2 power 2 means 4 and so on and so forth. So the value of I grows and shrinks. The size of the database is going to be growing and shrinking actually. So that the number of buckets are going to be arranged by us actually. So multiple entries in a bucket address table may be point to the same bucket Because the same thing happens as in case of our previous hash function. Here also the dynamic hashing also it returns. But remember, when the data is going to be returned, that may be valid up to 32 bits actually. So actual bucket is going to be, number of buckets are going to be, the actual number of buckets are going to be less than 2 power I, as I is the bit. So the number of buckets also change dynamically due to the splitting of the buckets and the correlation of the buckets, etc. So general hash function is like this. For example, you observe 00011011. The remaining bits I am not considering, 2 bits only. That is 2 bits means 4. If third bit is there, 8. Fourth bit is there, 16 buckets, and so on and so forth. So in this structure, I2 is equal to I3 is equal to I, where I1 is equal to I minus 1. So based upon that, the data is going to be arranged. So if I1 and this is going to be mapped. I2, 1, 0. I3, 1, 1. And so on and so forth. This is the bucket address table and this is our buckets. In each bucket, depending upon the size of the buckets, number of tuples are going to be stored actually. So here if we say it has been shown as a 3-bit here. So as I told you, 3-bit means 8 buckets are there, right? Global depth is going to be D is equal to 3. So that's why we are going to consider the local depth of each bucket is going to be considered, and the values are going to be stored as a D dash is equal to 3, D dash is equal to 3, and so on and so forth. The bucket for the records whose hash value is 00, whose hash value is 1, and whose hash value is 2, 3, 4, and so on and so forth. So, what is the advantage of extendable hash function? Each bucket j stores a value ij, and all the entries that point to the same bucket have the same values on the first ij bits. So, first ij bits it will be the same. And to locate the bucket containing a search key kj, we have to find the hash function on that particular kj. As usual, we will get some value x. Use the first high order bits of the x. That means x some value I'll get, no? Convert into binary. So whatever I am considering, in the previous example, 3 bits we consider. I value is 3. I value is 4, like that. So the first 4 bits, first 3 bits are considered, so that the x is going to be displacement into a bucket address table and follow the pointer to the appropriate buckets. Same insert also. It has to find out where is the position or a space is available by using lookup and locate the bucket, say J. And if there is a room, you are going to be stored in the bucket J. Insert the record in the bucket. Otherwise, the bucket must be split and insert reattempted. Overflow buckets used instead of some cases also. You can split and readdress it, or we can use overflow bucket as in case of static function. So the split of the bucket J when inserting a record with the search key value K should follow the constraint as if I is greater than Ij, more than one pointer to the same bucket, and allocate a new bucket J. Accordingly, update the second half of the bucket and address table originally pointed to the J and to point to the Z. A new bucket added, no? So half of the bucket entries are going to be moved to the new bucket actually. Remove the each record in bucket J and reinsert the data actually. So like that, while inserting, we have to make a space. Making a space is nothing but add either overflow bucket concept or split the existing bucket into 2 buckets and give the another address. And same deletion also. First, we have to find out the location of the bucket and remove it. If the bucket itself can be removed, it becomes empty. So that's why we have to appropriately merging process has to be done with the coalescing of the bucket can be done. So whenever we are using this coalition of the buckets, then automatically only a bucket having the same value ij and same ij minus 1 prefix, will be presented and the other bucket is going to be deleted. Like that, decrease the bucket address table size is also possible actually. So for example, use of extendable hash structure, biology, computer science, etc. H of department name we have to consider. So biology, BIOLOGY, we have to consider the respective words are going to be represented actually. And according to that, the hash function is applicable and it will calculate hash prefix and bucket number also. Bucket address table is going to be stored in our hash prefix with a pointer actually. The hash structure after insertion of two names, Mochran and Srinivas and W, that is view, records are going to be added, two records. So hash table is going to be, bucket address table is increased as well as the hash indices are also increased. Similarly, 2 and 2 means 1, 2, 2 will be there. Similarly, inserting another two elements, gold and EA, then automatically the records are going to be added. 3 no, so hash prefix is 3, the number of buckets are increased. That means if keeping on changing, automatically, dynamically it changes the number of buckets. It may be overflow concept or by using a splitting concept also. This extendable hashing function as performance does not degrade the growth of the file and minimal space overhead is there. Because we are storing hash indices, separate table, etc. So space is required, more space, but that is also very minimal. It need not be that much considerable complexity of space utilization. But this has the disadvantages also because extra level of indirection to find the desired record. Bucket address table may be itself become more sometimes very big also, and memory space may not be sufficient to store our bucket table and cannot allocate very large contiguous areas on the disk also. Changing the size of the bucket address table, the solution can be considered to be as the data can be stored by using tree index structure actually. So that's why this bucket address table going on increasing. So that's why size can be increasing. It cannot allocate very large contiguous areas on the disk either. So the solution is we can discuss or we can move to the tree indexing structures. That is B plus tree structure can be used to locate the desired record in a bucket addressable table actually. The size of the bucket address table is an expensive operation. Changing the size of the bucket address table is an expensive operation, but it has been doing in our extendable hashing function. It will take more cost actually. And linear hashing is an alternative mechanism to this extendable hashing, which allows incremental growth of its directory. Not like splitting, etc. Incrementally equivalent to the bucket address table at the cost of more bucket overflows are going to be used actually. So while comparing this order indexing and hashing, cost of periodic reorganization and relative frequency of insertions and deletions, in case of order indexing and hashing, we can consider it is desirable to optimize average access time at expense of the worst case access time. So what are the questions generally we learned? Hashing is generally better at retrieving the records having a specified value of the key. If the range queries are common, order indices to be preferred. So individual queries are there, hashing is better one. Range queries are there, then order indices is going to be considered. In practice, in PostgreSQL supports hash indices, but discourages use due to poor performance. It supports, but not generally considered to be as a very frequently used actually. Oracle supports static hashing organization, but not hash indices actually. File organization is supported in Oracle, but not the indices actually. SQL Server supports only B plus trees, but not hashing. So this is the brief description of hashing technique. So depending upon our need, we have to choose which technique is suitable, which hash function is suitable to our applications based upon the database continuous or growth and shrink of the database happens in frequently or infrequently. Based upon that, you can choose the type of the hashing function, hashing technique, as well as the respective hashing function also. And partition hashing is also there. Hash values are split into segments that depends upon each attribute of the search key. N attributes of search key is there. Then we are going to store in a various attributes. For example, n is equal to 2. That is, two attributes are there. Customer, search key being customer street and customer city. So to answer the quality of the queries in a single attribute, we will store the value of the combination of these two search keys. The respective hash key will be generated by us. Then we need to look up multiple buckets similar in effect of the grid files, which we will discuss while already we discussed in B-tree concept. Bitmap indices as well as the grid indexing structures were introduced along with the B-tree indexing structure. This material is collected and used taken from the prescribed textbooks by Henry F. Cont as well as Navati. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.